are in listen-only mode.
Hi, and welcome to the PASS Business Intelligence Virtual Chapter webinar for today. We have a great presentation that we're looking forward to. It's going to be by Rob Biddle, and it's on loading a data warehouse with SSIS. Before we get started, of course, we've got a few introductory slides that I'm going to go over, so we'll take just a few minutes to run through those, and then we'll jump right into the presentation. So. Just a couple of news items, of course. If you're planning to attend the PASS Summit, you probably want to register before July 12th to get a very large discount. Number one, there's a early bird quote discount, and then also if you use the code that's showing there, the VC15BRD5, that will get you an additional $150 off the registration. So definitely would be beneficial for you to utilize that for your registration process. So again, that's up until July 12th. After July 12th, the rate goes up and the early bird discount is no longer available. Of course, whatever your passion is for SQL Server, there is probably a virtual chapter or a local chapter that applies. So make sure you take a look at the different virtual chapters that are available. Some of those are very topic specific, some of them are location specific. So there's definitely something, I think, to interest everyone. Talking about virtual chapters, as you can see from this slide, there are several upcoming meetings, including a couple today. There's one later this afternoon from the professional development. And then, of course, later in the month, there are several virtual chapter meetings. And you can go out to the PASS website and always register for those. Even if you're not, quote, a member of that particular virtual chapter, they're available for you in order to jump out and see a wide breadth of different topics. If you want to see what all the different ones, this is just a select group of them, you can always go to sqlpass.org/events and be able to see that. Of course, there's the SQL Saturdays that we wanted to mention. There's several in North America that are coming up, July 11th in Columbus, and then you have Sioux Falls, and then Sacramento and Albany through the rest of July. And then, of course, internationally, you have one in Manchester, Odessa, and Beijing, all on the 25th. So again, SQL Saturdays are a great opportunity for you to get free training. I highly, highly recommend that you plan on attending one if you have one nearby. Volunteer opportunities. Of course, all of us are volunteers that are helping with the PASS community. In particular, I'm one of the co-leaders for the Business Intelligence Virtual Chapter, but there's plenty of opportunities to volunteer for your virtual chapters and even in person. So please feel free to go out to volunteer.sqlpass.org and sign up, and you will pick your interest, and from there, someone will get in touch with you on ways that you can assist with the community. Of course, there's a wealth of different ways to keep in touch with SQL PASS. You have LinkedIn, Facebook, Twitter, and then the PASS website, of course. Those are all available for you to take a look at to keep in touch. And again, all the events are showing out on the PASS website. So just to kind of make a mention, as I said earlier, there's a wealth of opportunities. One of the things that they wanted to make sure to emphasize is that in addition to the normally scheduled virtual chapter meetings, there's several that actually have them on a set day. So for instance, like the performance virtual chapter is the fourth Thursday, and the DBA virtual chapters the second Wednesday and the fourth Wednesday. So again, those are always available, just to kind of mention they're out and they're available. So that's the introductory slides. What I'm going to do now is I'm going to go ahead and change our presenter, so it'll take me a second to do that. But while I'm doing that, I just wanted to mention that today's presentation is by Rob Biddle, and Rob works out of Orlando for Hilton Grand Vacations, and he is going to speak on loading a data warehouse with SSIS. So at this time, I'm going to go ahead and turn it over to Rob, and then we'll jump in about 5 minutes before the end of the presentation with questions. Feel free to always go ahead and post those questions as we go, and I will go ahead and read them off to Rob near the end of the presentation. So Rob, I'm going to go ahead and turn it over to you.
Great, thank you.
Um, Thank you for attending. Today's topic is loading a data warehouse with SSIS. I'm your presenter, Robert Biddle. Just a bit about me. I'm a data architect for Hilton Grand Vacations. That's the vacation ownership brand for Hilton Worldwide. I'm a certified DBA and database developer, and I'm currently pursuing my MCSE for the data platform. I'm also an author for MS SQL Tips. If you go to that site, you're going to find out relevant articles posted by me in regards to incremental data loads. It's a really good follow-up after this presentation. You can tie those two together really nice. I'm very active in the PASS community. Actually, I'll be doing a presentation in Albany in a couple weeks, if you saw that on the Scott slides previously. I'll be covering .NET for the data professional, which is a little bit different than what we're covering today. Contact information is below, email, Twitter, and blog. My blog mostly contains links to other presentations I've done for either SQL Saturday events or Code Camp events. Today's agenda, first we're going to get everyone on the same page. Some of you may have come from a background of data warehousing already. Some of you may already have an SSIS background. What we're going to try to do is get everyone on the same page. So first we're going to cover some of the basics like dimensional modeling and what that's all involved with. We're only going to spend about 10 minutes or so on slides. We're going to be more demo heavy here. Next, we're going to do an overview of the incremental load methodology and generally how that logic works. In the demos, we're going to look over some frequently used transformations, and then we're going to load our dimensions and then fact table. So, why a data warehouse? Getting back to the basics here, we want to build a system that is the main data store for reporting, and we're going to load data into the system in a fashion that will allow it to be queried efficiently. So in the process of doing that, we give ourselves additional functionality. We'll have historical tracking, and our queries are better performing specifically for OLAP systems. Overview of the dimensional model. So dimensional models are often called star schemas because of their shape. You'll see over here on the right, I have a little thumbnail of a model. The center of it is the fact table, and it contains numerical data, and it also contains keys that joins to other tables called dimensions. And they'll also have keys that are for dates. Typically, they'll have very few columns but many rows. Usually your fact table will be the largest table in a dimensional model. For dimensions, it's a bit different. So you're not going to have a lot of numerical information. It's going to be mostly text and descriptive data. The tables are going to be short in terms of row count, but often many columns. And then the data is going to typically be denormalized. You'll combine lots of tables together to reduce joins. By reducing joins, we can increase the performance of our queries. Also, with denormalization in dimensions, we typically will have hierarchies that we'll build. And we do this because it's very beneficial to the OLAP design. One common pattern in data warehousing is to retain historical data for dimensions. Well, we refer to these as slow changing dimensions. So when an attribute changes in our source database, we need to determine how we want to reflect that change in the data warehouse. I have here the most common attribute types that we look at with slow changing dimensions. So the first is type 0. In type 0, we don't really change anything. The data gets updated in the source, and we determine that that information, whatever it is not really important, so we decide we don't want to update it in the warehouse. Type 1 is just a simple update. So for example, in our source system, if we had a salesperson and we wanted to update their last name, they were married, we would reflect that same exact change in the warehouse by updating that last name column. We determine that that field isn't valuable enough to necessarily retain history, but we want to have the most current up-to-date record. Then it gets a bit more interesting when we have a type 2 scenario. So what we decide is that we want to have the original record and we want to have all changes and persist them over time so we can see point in time how things have changed. So what we do is we first update the existing record and we mark it as expired, and then we insert the newest and latest and greatest record as our change record. A good example of this would be if our same salesperson changed departments. We would think that by changing their departments, maybe their performance would be more interesting to measure than, say, like changing their last name. Lastly, we have an example. It's type 3. And type 3 is, rather than doing row-based history tracking, which is how type 2 works, we would have columns. So for example, we may have 4 columns in one row. And what we do is typically use that for statuses. It's not a very common pattern, but it is something you should be aware of. Table design standards. So in our demo, we're going to apply some standards that are very common. First, we're going to prefix our fact tables with fact and our dimension tables with dim. We're going to camel case our column names. And then we're going to use surrogate keys. So this is something new if you're not familiar with data warehousing. This is essentially a primary key for our dimension table. When we keep multiple historical records for a dimension, we can't use the same primary key from our source system. It would cause a duplicate error. So, for example, our customer ID here, we're looking at this record below. I have a customer AK of 730. That is the customer ID from our source system. If I had a change for that record and wanted to have a slow changing dimension type 2, I can't pull in that same record as the primary key. So what we do is we create a surrogate key and we make that unique. We link those surrogate keys up to our fact table. Along with this terminology, this customer AK, you'll also sometimes see BK or NK, that's a business key or natural key. They're all synonymous. For dimensional modeling, there's a 4-step process. This concept was created by Ralph Kimball, and it's outlined in great detail in the Data Warehouse Toolkit, which I have listed as a reference in the end of my slides. The first step for dimensional modeling is we want to identify a business process of interest. Now, if this is your first time building a warehouse, it's a recommended practice to pick the most important yet not complicated process of the business and work with that first. It'll be the most interesting and you'll get the best results from your project. So in the event of retail sales, you may want to look at the sales table, insurance claim processing, so claims, students and enrollments are some examples we have listed there. Declare the grain. So we want to figure out what level of granularity we're going to be querying against. The recommended practice is to have the most atomic level because we can always aggregate and get our detail summed up. However, there are some cases where you may want to have some pre-aggregation done. It's very dependent on your requirements. Choose the dimensions. When you're determining requirements for your data warehouse and you're speaking with the business users, you should ask them how they would like to have some of this important measurement data represented. Would you like to see sales, and how would you like to see that? Would you like it broken down by product, by demographics, by sales date, by sales center, etc.? Every time you use the word by in your question, those are attributes of your dimensions, and that should give you a good indicator of what you need to include in your model. Lastly, we identify the fact. So after we've determined the business process and how granular we want it and all the key players, we determine what metrics are of interest, and we should have everything pulled together at that point. Incremental load methodology. I have one demo that covers this. However, my row versioning article on MS SQL Tips covers this in great detail. I would strongly recommend giving that a look over if you find that you want to do incremental loads. The methodology can work for example, any of these other items I have listed, such as date, time, identity, or you could even use it with change data capture LSNs. And now we're going to jump into the demo. So we have a few databases here of interest. We're going to be working with our source system is AdventureWorks 2012. I have done the work of creating a data warehouse Kimball model or dimensional model, and this is my AdventureWorks DW 2012. Here's the list of tables that we have. If you'd like to see a data model, let me zoom this in so you can see better. Well, maybe we'll try 75%. There we go. So here's our center table. It's the fact. And we have on the left side, far left, we have this dim date. This is a very common practice in Kimball methodology to have a date dimension. And what you do is you have keys from your fact that go to this date dimension. And then we have additional dimensions here. So to begin the load, I'm going to first load the date dimension, which is this script here. This is a generic one. There are a lot of different date dimensions you can find on the internet. Everyone has their own personal ones they create. This should be more tailored towards your business. For example, whatever company you work for, their fiscal year is not going to be the same as mine. So it's just going to be different. Holidays are going to be a little different. So we're just going to run this. And you only ever have to populate your date dimension once. It's not something you need to do regularly. And now let's take a look at the data. Just kind of getting the main works for it set up. So you'll see this is a very common practice. We have a date SK, and this is an integer. It's used for performance reasons. Date time is a 8-byte data type, and this is a 4-byte data type. SQL Server also tends to work very well with integers, so this process seems to work out really well. And I started this from 1990 on up. My default one here I have is this, in the case of an unknown date, we'll have 1900-0101. That's a common practice as well. When you go to the OLAP layer after you've built the data warehouse to build cubes, you can identify inferred members there, and then you can set that as an inferred member. So that way they can display that this is an unknown date or a null date in the reports. I have a mapping document that I built here as well. So what I did is I tried to take the approach where I didn't really know much about AdventureWorks. I have a few general ideas about it. It's a fictitious company for selling bicycles online. So I tried to approach it as if I was a new employee for the AdventureWorks company and trying to build out their model and populate a warehouse. So I took the most important business process there, following our 4-step methodology, and I homed in on sales. If we look in our source system, everything is conveniently grouped together. We have a sales schema, so that made it pretty straightforward on where to go. Sales order detail and header, those two things combined had most of the metrics of interest that I saw. I found that the model that I created was very different than the default one that comes with Microsoft's sample data warehouse. So it's interesting to see to compare how things were built. But you'll see here how I have things listed. I've got all my SKs together just so for convenience. And this helped me model out when I went to go to build out the tables. I have all my metrics separate: order quantity, unit price, discount amount. And then we have our dimensions. Now in some cases you're going to want to combine source tables together. For example, products. I decided we would combine the subcategory together with product and denormalize that. That's a pretty sensible approach for this. Promotions, very straightforward, nothing really of interest. Geography, it looks like, as you see here, there's a source table and a source table 2, which would mean that I did some denormalization there as well. Same for customer. Looks like I combined something here. Customer and person. Employee and person, and also email address. So now we're going to go into the demo for creating this. The first package we're going to cover is going to be promotion. And this is a insert-only pattern from a single table that we're going to be doing. All I've done here in this environment is created the connection manager so we don't have to spend extra time doing that. So first, what we're going to do is we're going to insert an inferred member. We're going to do this for every dimension. What the inferred member means is, in the case that we have an unknown value at any point, we want to have something to put in our fact table. And that is the inferred member. We don't want to have nulls, because nulls means we start using left joins and then we start reducing our performance, which is something we really don't want to do. So I'm going to choose my data warehouse for this. And I believe I have stored procedures for this already. And we'll review that so we can see exactly what's happening there. So insert inferred member promotion. So first what we're doing is to check whether it exists or not. We're going to do an identity insert with -1 as our key value. So in the event that we don't find this record, we'll insert it. And this will be safe to run every time. So that way, if we reload the warehouse, it won't be a problem. So I'm just going to grab that stored procedure name, and I'm going to jump back to my project here. Then we're going to extract our source data. So we're going to create a data flow that connects. And then we'll go to OLADB source. OLADB is usually the preferred method to use in SSIS over ADO.NET. If you come back from a development background, you're probably more comfortable with using ADO.NET. But for performance reasons, it's very common that we use OLADB in SSIS. So I have some source queries already created, so I don't have to type in a demo. We don't want to do that. And I'm pulling data from this special offer table, which is listed in the mapping spreadsheet. So I took the time to figure out, where these things might be. And I did that by looking at the sales order detail and sales order header tables and said, well, what are these things keying off? What are they connecting to directly? That seems it may be interesting. And that's how I came to special offer and promotion. So do a preview just so we can look at some data. Next, we're going to do a lookup transformation. The lookup transformation has several uses. It's effectively working like a join, but you can use it also like an exists type, like a left join. And that's how we're going to use this here. We want to look up for records and determine whether they exist or not and handle them appropriately. This is an insert-only pattern, so if it does not exist, we want it to continue down the flow, otherwise we're going to ignore it. Specify how to handle rows with no matching entries. We're going to redirect rows to the no match output is what we're going to do with these. I'm going to use the results of a query. And let's pick the right database. So what this is doing is says, give me the promotion AK from dim promotion. So that's the source key from special offer. And what we're going to do is join this key from our data warehouse to our source query. And if they match, we're going to ignore it. If they don't match, it will proceed. So what we do to make this join is we go to columns, and lastly, we're going to load it. So we want the lookup no match output. And this is going to dim promotion. Here we have some options: keep identity, keep nulls. We're not going to use either of those since we're not keeping keys from the source. We're generating them with surrogate keys. These rows per batch and commit size we want to leave as the defaults. What that's going to signify is that we want to commit it all on a single batch, and if it fails, we roll back the whole thing. I tried to name the source columns to match nicely. It looks like I may have missed some. So category to promotion category. And it looks like min and max quantity are also here. Were missed. So now we're going to execute this. And it completed successfully. 16 rows were found. Now using this pattern, it's safe to rerun it as many times as we want now. It's an insert-only pattern. Because we did the lookup, notice we don't have 16 rows going past the lookup transformation. An interesting thing about the lookup transformation is that it caches the rows before we start if we use the full cache setting. So you notice here, lookup process 17 rows in cache. Caching actually is very fast with the lookup transformation as well, so it's not something you should be afraid of unless you're doing maybe hundreds of millions of rows that are wide tables, then we have some issues. But caching with like a lookup key like we did is a really great practice to determine whether data exists in source versus destination. And it's great because usually your warehouse is going to be on a separate server than your source system, at least it should be. So it's a real good transformation for that. The next we're going to do is sales territory. What we're going to do is do some denormalization. We'll also use an insert-only pattern for that. We'll go a little faster here because there's some repetition. For example, we have to have an insert inferred member every time. So let's go to sales territory and get that procedure. And then we'll do a data flow. OLEDB source. As you see, oops, I clicked the wrong thing. As you see, I have all the scripts here provided in the demo. So all we're doing is just doing a join at the source, nothing terribly fancy in a lot of cases. When we do incremental loads, we will often have to have some interesting where clauses to determine which piece has changed. So that can be a bit more complicated. And we'll do another lookup transformation. NoMatch Output, connection. Again, we're looking up what's in the warehouse already. And then we're joining it. Let me just double check there. Yep, redirect rows to NoMatch Output. Good. And OLADB destination. We're loading to the warehouse. And everything looks clean. So very simple, very similar to the one we had just done. Just a little bit I've added to it. Next, we're going to show a derived column transformation. Derived column transformations are useful in the event where you want to manipulate data, but you want to do it more so in memory rather than using a SQL query to do it. There's benefits to both. For like lots of complex string manipulation, a derived column transformation could be nice. Sometimes it's nice to just put it in there so you're not running something heavy scanning against the database indexes. Also, script tasks, script transformations could be useful in the same way. They can be very expensive and slow running, but it would be even worse if we ran it against SQL Server. So we've got another package here. And the next one we're going to cover is product. So again, we're going to start off with an inferred member. Apparently I typed that wrong. And then we're going to choose product. All right, now we go to a data flow task. And you see a lot of this stuff is kind of looking similar. Source is product. See what we have here of interest. It looks like we're doing some joining. So a little bit more denormalization. There's some left joining. So it looks like we're going to do something with probably nulls, would be my guess. Because we don't want nulls if we can avoid it. We'll do a lookup transformation here first. Check to see if data is already loaded. Just as we have. We'll look at other ways to handle that too. So like we'll update history, for example. And let's join product again. And now we're going to do our derived column, just this guy here. If you already have experience with SSIS, you probably have worked with derived columns quite a bit. If you come from other ETL tools, this may be a bit new to you, but the concept should be pretty much the same. So I have some script information here, so I'm not going to type. So what we're going to do here is we're going to use the SSIS expression language. It looks a lot like SQL or kind of like .NET even, but it's not. It's its own thing. And we're going to replace our nulls. We could have done this in the SQL layer, absolutely, but we're doing it here in SSIS instead. So derived columns will say that we can replace the existing or add a new. So what we're going to do is replace subcategory name with this formula. And the next one we're going to do is product category. Pay attention to these data types also. Sometimes when you do an expression, it can convert a non-Unicode string to Unicode, and that can be very problematic. There's a way you can change the end result data type that will correct that. I'll show that to you in a minute. Because otherwise, when you go to try to load a non-Unicode or Unicode value into a non-Unicode column, you're going to get an ugly metadata error. Let's replace color. What this expression, for example, says here, I have it highlighted on my screen. It says, in the event that color is null, the question mark says, then we replace it with a blank character. The colon says, then otherwise we just replace it with color, just to give you some information of what's happening there. And the last one here is product model name. So this should take care of our nulls. And again, we're loading it to the warehouse. And to product. Just make sure everything's good here. Yep, product category. Finished good. So we had a couple missed matches, no big deal. Sometimes when you are developing your tables and creating those, you may end up specifying a lot of not null constraints in your dimensions. That's very common. Or if somebody's doing it for you and you're just doing the loading, that may be a thing. So just be aware of it. It's a very common case where people like to have blanks rather than nulls for descriptive data. It's the reason that it's for OLAP optimization is the most common. And you have to be consistent about these things. Establish these rules up front with other business intelligence developers on their project so that if you're going to have nulls in those particular areas, that it's very clear that it's going to be the case. You don't want to have it sometimes null and sometimes otherwise. That could get very confusing. Next, we're going to look at is a stage pattern. Staging is very important in ETL development for data warehousing. The data warehouse toolkit, the data warehouse ETL toolkit, I'd say about 70 to 80% of that text covers specifically staging. It's a really interesting read and I strongly recommend it. What you'll typically use staging for is you have your data warehouse on a separate server than your source system, but there's sometimes you just need to join up source information like we have been doing. We've been doing lookup transformations, but sometimes it's really not enough, or you have to pull a wide selection of rows. to do it. So rather than buffering it into memory with the lookup transformation, we'll actually load that data to the disk on our destination server, and then we can do usually some scripts to compare. So again, another inferred member, and this one is going to be geography. And what we're going to do, rather than inserting directly to the table, we're going to stage to another database. By the way, for staging, it's also recommended you keep that data separate from your data warehouse, because there's going to be a lot of truncating reloading going on, and because of that, we want to make sure that we keep that separated, because you'll have growth going up and down, and it'll be very confusing when you try to do DBA tasks like monitoring how much file space you need, for example. Actually, before I get into the load task, we need to truncate our table and our destination, just as a reminder. And we're actually truncating and staging. I think that's what I'm using. Let me just double check here. Yeah. So we're going to do a basic load with no lookup. So a lot of times if you're doing a staging pattern, you may not need to use a lookup task, since you're going to be pulling a lot of the stuff on the disk. You can combine both to reduce how much data you're loading and reduce your overall time. So it's something to keep in mind. And then we're going to go right to destination, which is staging in this particular case. Now what we do at the end here is we run a SQL task that's going to do the logic that will determine what does and doesn't get loaded. Into the data warehouse. Jump back here again. This is probably a very basic script, and we'll look at one a little bit more complex here in a minute. So this is just doing a not exists, for example, fairly simple. Okay, great. The next one I want to cover is using the SCD Wizard, and I will give you some comments about that. It's very important to know. So the SCD Wizard, Slow Changing Dimension Wizard, is a very nice component that automatically builds a lot of the stuff we've been doing here. However, it does come with a price, in that it has some severe performance issues that we have to be very careful about. So we'll do inferred member first. Every time. And this is employee. and data flow task. And we'll have a source, and then we're going to have one transformation, which is the SCD Wizard. Source employee. So then we have that is, let's see if we can find it. There it is, slow changing dimension. And I'll explain why the performance issue exists as well. So just follow the instructions. Select dimension tables and keys. So let's pick our data warehouse. Table or view. We are loading to employee. It asks us what our key column is. There's our business key, which is our AK there. And then next, select a change type for slow changing dimension columns. Let's say email address, and I want this to be historical. So here you see fixed attribute would be type 0, changing would be type 1, and historical would be type 2. What we covered in the beginning. So you can either choose to use a flag, or you could use start dates and end dates. I think what we have is current flag. No, I don't want that. Usually like expiration dates. So start date is our load date and expiration date. And it asks what value you want to use, variable. You can create your own. These ones that are system are generated by SSIS, so you can just use those. So what this says is that when we have our date columns in our dimension, the start date will be the time that we load, and the end date will be our expiration date. We'll skip inferred member support. We already dealt with that issue. And as you see, that one transformation broke off into this thing here. So it's going to ultimately load to Data Warehouse 2012. And the performance piece that we run into is this oladb command. What ends up happening is this becomes single record updates. So in the event where you have a lot of changes in your source, then this component becomes a serious problem. So that's your indicator on whether this is a good pattern or not to follow. And the heuristics that I've heard from people changes. I've heard anywhere between 10,000 to 50,000. I've heard as high as 100,000. It depends on what kind of system you're working with. However, I'd say if you're doing 50,000 or less updates, it's pretty safe to use this component. There's also a lot of third-party components, some free, some not free, that do similar functionality, so that's worth a look as well. So we're just going to run this. And everything's good. So now if I go do a change to our employee, oh, wrong database. Do I already have a script for it? No, I don't. I'll have to figure it out. Let's look at our source query. Human resources employee set email address equal to Oop. Take out that E. Oh, that's in another table, isn't it? Sorry about that. So let's do that. Now let's rerun it. So pulled 290 rows from the source again. And notice the other path we went down is the historical attribute. Nothing went through insert, and union back and inserted that one update. So let's see what we've got. It's a dim employee. So there's the employee key. Am I looking at the right table? Let's move this webinar thing here. It's in my way. Nah, that would help. I am not in the right database. Oh. Let's just go here. That's what I get for typing in a demo. There we go. Excellent. So now let's go to the right thing here. Employee AK equals 1. Just do some filtering. You should see there is the load date, and notice we expired the previous record, and the newest one, this is the most recent, is null. All right, so we're running a little low on time at this point. What I'm going to do is show you the completed solution for the next couple patterns. We're going to go through it really quick. That way you can see how everything ties together. So the last pieces we have are the pattern is T-SQL merge pattern with an incremental load, which is very complicated for me to cover in a few minutes, but I'll go through it quickly. So we have our inferred member. We don't need to look at that. So what we would do next is we are doing an incremental load. So first we get our modified dates from the source system, or from our, so what we have is a metadata table here actually. And let's pull this up so you can read it better. And what this says here is get our last successful modified date from our metadata flow. It's a table we keep in staging that keeps historical tracking of the last date we successfully loaded. By default, we're going to just say if it's null, then anything from 1900 to 0101 will be perfect for us. We use a staging pattern. We load our data to the staging table, and then we do a T-SQL merge. And this performs really well. we have is an insert, and this is going to do a merge using our staging. When not matched, we insert. When matched, we update. This is doing a type 2 slow changing dimension. This is the recommended practice to follow in the event that you have too many updates in your source system. Now, mind you, because we're doing an incremental load also in this, we're looking at specific dates. These question marks represent parameters. The parameter mapping is set here. These are the variables we populate in the beginning of the data flow. So what we have here is kind of an optimal solution for loading data. So we're pulling the least amount of information from the source system, and we're making sure we load it in the fastest possible time using a staging pattern. So after we do the merge, we update our modified date and our metadata flow table with our last successful modified date. It's definitely by far the most complex load that we'll have will be this pattern. And it's ideal if you can use this pattern in large systems because you can run this continuously without really hammering your source system. In fact, the more often you run it, the less issues you'll run into in terms of performance and load times. The very last one we're going to look at is sales. And what we're going to do is, can you hear me? Okay, yeah, I was having some audio issues. What we're going to do is join up everything. As you see, we have this calculation here, this year piece here, where it's year order date times 10,000. What we're doing is converting our date into that integer field. And then we get all of our keys. And lastly, we do lookup transformations. And this is a repeated process. And in the final, we load to our destination table. So I'm just going to run these last two so we can complete the package, the whole solution. And if I didn't miss a table, this should work out. And it's completed successfully. So there we've used this methodology to load a Kimball-style data warehouse using SSIS. And that completes the demo. And I'm going to bring up the resources page. So at this time, I'll take any questions if anyone has any.
Hi, Rob. We do have a couple questions, and one of them, several of them pertain to if the scripts would be available somewhere that you ran through for the presentation.
Absolutely. I've done this presentation a few times at SQL Saturday. If you check my blog and scroll through a bit, you'll find several links to it, different versions of it. So those will be included along with the scripts with the full demo, database backups, everything. And I'll also get an updated link at the end.
Sure, and y'all can see on the contact information, there's Rob's blog page from WordPress that you'll be able to utilize. So I know that's the number one question. Another question people ask, is this being recorded? Yes, it's being recorded, and we'll get it posted to YouTube. So with that, I've got a couple of more technical questions. One question that came up is, how do you design dimension tables so that it can be shared between different fact tables?
Oh, that's a great question. The terminology for that they use in Kimball methodology is called a conform dimension, and that is the ideal process that you want to have. So it takes time to do that. Uh, you can share them. It's just it's just a link. But what you're going to have is you may have data duplication already in your enterprise, and you have to address those issues where people aren't necessarily using the right data sources. So maybe master data management may be something you want to look into if you have a lot of issues with getting conform dimensions.
Okay. Good, exactly. Another question that has been asked, and it's kind of in actually a couple different times in different ways, but is the question that came up is the main reason to use staging tables because you have so many rows, you don't want to put them all in memory?
Staging tables, the times I find that they're most useful is when you want to do large joins or complicated logic between your source and warehouse, and I find that it alleviates a lot of that issue.
And then another question that came up, and this comes up fairly often, is the slowly changing dimension feature only available in the enterprise version?
I believe that's not an enterprise only
I thought so
feature.
too. Thought so too. Let me see. I think there were two more questions. Let me scroll a little bit here. No, most of the rest of the questions, let me make sure I caught them all. Questions about recording. Okay, this one just popped in. Do you recommend that SSIS and SQL Server be on different machines or on the same machines for large databases?
The footprint of SSIS itself is very small. However, the lookup transformations, if you have very large ones, that is done in memory on that same server where SSIS is running. So it may be beneficial to put it on a different machine if you are running into very large transformations.
Okay, see if anything else. Okay, the next question, and this will probably be the last one, is there any recommendation on how many dimensions are appropriate in a star schema?
Not that I know of. I've seen star schemas with just dozens, and it looks very strange, but yeah, it works.
Let's see. I don't see any other questions that have popped in, so definitely want to thank Rob for taking the time to do the presentation today. We're very appreciative here at the Business Intelligence Virtual Chapter for all our volunteer speakers. As Rob mentioned, you can go out to his blog and take a look at some of the details from the scripts and download those if you read through his blog. The recording will be made available. It sometimes takes a few days, up to a week to get through the process of getting onto the YouTube site and then onto the past website and getting the channel all updated. So those will all be posted shortly for you to take a look at. Again, thanks, Rob, for the presentation today. And just wanted to mention that we do have another virtual chapter presentation is coming up next week. You can go out to the BI virtual chapter website on the SQL Pass website and go ahead and register that. And we look forward to that on the next conversation. Again, thanks everyone for attending.
Thank you.